Hey guys, in this video we're going to be talking about a bicycle fork. Now, a bicycle fork is a component of a bike that holds the front wheel to the frame and it pivots to allow you to steer. The concept of it remains the same no matter what type of bike you ride on. So let's take a look at the shape of a normal bicycle fork. So if we come down here, we see that a fork consists of two blades, both of which come from the frame and they move down and attach to the front wheel. Here are the specific parts that make up the shape of a bicycle fork. First, we have the steerer. Now, this tube attaches the fork of the bicycle to the bicycle's handlebars, which allows the rider to steer. Next, we have the crown. This is where the blades of the bicycle fork are joined together before they split off. Next, we have the blade. When a bicycle fork splits from the crown, two blades come down to eventually lock onto the front wheel. Next, we have a dropout. Now, at the bottom of a fork, dropouts will actually hold the wheel in place. And lastly, the offset or rake. The angle of the bicycle fork changes as it moves down to the dropout. This allows for the suspension mechanism to work and also helps with absorbing shock. So if we come down a little bit further here, we see a distinct difference between a normal bicycle fork and a mountain bicycle fork. With a normal bicycle fork, we have, of course, the steerer, the crown, the blades, and lastly, the dropout. Now, what's different between a normal bicycle fork and a mountain bicycle fork is that there's a little bit more complexity to it with the suspension. So we have the steerer as normal, the crown, and from the crown we have these things right here, and they're called stanchions. Now they're a stiff post that slides into the lowers. Stanchions. From the stanchions, we have this thing called the arc. Now, this makes sure that both of the blades are working together and not working independently. Because if they're working independently, it would probably be a major disaster. Lastly, we have the lowers. Now, these are what hold the stanchions in place as they slide into the lowers. And then, of course, lastly, we have the dropout. Now, you can see the distinct differences between them and what makes a mountain bike so more complex. So just to get into the suspension a little bit, most bicycles, especially mountain bikes, will contain a set of shock absorbers to absorb the impacts of the road and trail while riding. We're just going to do a little brief overview, and we're going to get into suspension later on in another video. But right here, we have the spring, and that's what's inside right here. The spring is used to store mechanical energy and is made out of either steel, titanium coil, or even compressed air. Next, we have the damper. Now, the damper is this thing right here, or dashpot, I should say. It's a mechanical device which resists motion via viscous friction. Now, although there are some variations with bicycle forks and their suspension, most of it is actually pretty standardized. If we come down a little bit further here, we're going to get into the dimensions. Now, do the dimensions change at all between different bicycles? And yeah, of course they do. A bicycle fork, depending on, yes, the dimensions change on a bicycle fork depending on several key dimensions that can make a bicycle easier or harder to turn and navigate. And here they are. First, we have the offset and rake, and we kind of got into this a little bit earlier. The point of an offset is to reduce trail. Trail is the measurement which will give us the best indication of how fast a bike will steer. Too much trail will make a bicycle harder to steer, while less trail equates to faster steering. So depending on what type of bike you have and what it's used for, sometimes the angle, which you will see right here, can be a little bit larger or a little bit smaller, depending on how close or farther away the fork is. Next, we have the length. Now, the length is usually measured by the parallel of the steer tube from the bottom of the lower bearing race to the center of the front wheel axle. So all I'm really saying right here is that from the steer all the way down to the front wheel axle, that is the length of a fork. Next, we have the width. Now, the width is also called spacing. It's measured collinear with the front wheel axle between the inside edges of the two fork ends. Again, all I'm saying is this spacing right between both of the blades of the fork. Next, we have the steer tube length. Now, the steer tube length is sized whether to accommodate the headset bearings in case if it is threaded, or to contribute to the desired handlebar height in case of a threadless headset. We'll get into headset later on, but again, all I'm saying is this thing right here, the steer tube length. And lastly, the steer tube diameter, you could probably guess it, is this little thing right here. And that is the diameter of the steer tube, which should be greater or in relation to the headset length plus the stack height of the headset. Now that we know all the dimensions, this is basically a bicycle fork.